All right, class. Yesterday we finished chapter 2, and today we're starting 3.1, which we're going to learn different power rules and things about functions known as derivatives. Yesterday we learned the formal definition of a derivative, which is f of x is equal to the limit as h approaches 0, f of x plus h minus f of x all over h. That doesn't look very pretty, and as we demonstrated yesterday, it takes a long time to develop it. So I want you guys to get out a piece of paper and split your paper into 3 parts. That should be a K, W, and L. This is what we know. So what we learned yesterday, what we want to know, and what we have learned. So go ahead and fill out that paper. And on that paper, in the no, I want you to put this formal definition of a limit. All right, so now that we know what our K is, what do you think we should want to know about this? Do we want to know more about this function, or in math, do we want to know a shortcut? Does anyone have any ideas? Yes, Susie?
We could use the power rule.
We could use the power rule. And where did you find that power rule?
In chapter 3.1.
Perfect. So, and the power rule would be an easier way, correct? So let's do the power rule here. So that's what we want to learn, because we don't know about that yet, but we're going to learn about it. So now we want to relate this back to what we knew from yesterday. If we were to have a function, and it had a constant and a variable, the power rule states that you take this that it is raised to and you multiply it by the constant. So your first step is 2 times 3 to the x power. And you assume that this is still a squared. This exponent in the power rule, you subtract 1. So this is 2 minus 1. This is the derivative of your function. And you're going to simplify that. And can anybody tell me what that would be simplified? Jeff?
6x to the first.
And do we really need that first power there, or can we just say x?
You could just probably say x.
This is the derivative of 3x squared. All right, so now I want you guys to take out a piece of paper, and we are going to do a different function in the formal form and also in the power rule form. All right, so go ahead and get out your piece of paper. And on that sheet of paper, I want you all to write 5x to the 4th. And that's f of x equals 5x to the 4th. Okay? And I want you guys to start working on this part with the formal definition. I'll be around to check on you guys, and then we'll do the power rule with this function. All right, so everybody should be done with the formal definition and applying it to the function 5x to the 4th. Can anybody show me this on the overhead of what they did with this function? Stephen? All right, so you guys see Stephen's work, and it shows that it is at least 5 lines long, and you can't really simplify that in any way. There's only one way to do this, and there's only one way to plug it into this function. All right, so now I want you guys to use the W of today, and I want you to apply it to this function as well. All right, can anybody come to the board and show me 5x to the 4th with using the power rule function? Jeff? All right, so Jeff is going to demonstrate this for us, and we're going to see how simple it is using the power rule versus the formal definition of a limit. All right, so go ahead and start here, Jeff. Now while Jeff is working on this, can anybody tell me in the function 5x to the 4th, using these letters, what the n is? It's a 5, very good. So we are going to use 5, and our z we see is a 4. And so our new function will have 5 times 4, which is exactly what Jeff is showing. And we're going to have x raised to which power? The 3rd power, yes. So instead of going using this function and taking up 5 lines, Jeff has now demonstrated to us the power rule, and he used it in half of a line. All right? So now on your papers, Jeff, good job. You can go ahead and sit down. I want you to write a sentence about what we've learned today. I want you to compare the K, what we knew, and the W of what we wanted to know today, and write it in a sentence, which could be using pictures, functions, or words, whichever you choose, which is ever easiest for you, just to demonstrate how easy and how different these two ways are. Here is a student using the KWL worksheet. Given in the lesson, he's able to use this worksheet with pictures, words, graphics, or other symbols based on his English capabilities. If he's an English language learner, this will work perfect for him, so he can choose whatever he's most comfortable with and doesn't feel distant from the lesson. This reading strategy was chosen because it connects previous material to the current day material and is easy to relate from day to day and step to step. This is perfect for doing the formal definition of a derivative and relating it to the power rule.